Welcome to section 4.3, graphing equations with slope. If the first 6 questions that I will be demonstrating don't really coordinate with an exact problem in the text, so feel free if you don't need a review on rewriting an equation from standard form to slope-intercept form or slope-intercept form to standard form, feel free to skip forward in the video until question number 7. For those of you who want to go through this, just as a quick kind of review and maybe a little bit of help to rewrite from standard form to slope-intercept form. The standard form of a linear equation has the x and the y on the left side of the equation. In fact, standard form is technically ax plus by equals c, meaning that I have some sort of coefficient in front of the x and a coefficient in front of the y equaling my final number. This is standard form. Slope-intercept form is y equals mx plus b. The y stands for the same y in the standard form, and the x stands for the same x as the standard form. But in this case, we have m, which we've already learned in previous sections, that m is slope. So it's kind of a convenient form. And b happens to be the y-intercept, meaning where the line will cross the y-axis. And the y is the tall axis, just like the letter y is tall compared to the x. All right, so the first thing we want to do is move the x over because we're isolating the y. Right here on the slope-intercept form, we want y to be all by itself on the left side. So here, to isolate the y, I need to remove the 8x. In front of the 8, there's nothing, which means it's a positive 8x. So to get rid of it from both sides, I need to subtract 8x. I'm going to just copy this, paste, oops. There we go. So now I'm going to show that we're going to subtract 8x from the left side, which means this cancels, and subtract 8x from this side. Now, usually we do whatever is out in front and we subtract 8x like this. However, we want it to look like slope-intercept form, so I'm going to subtract the 8x in front of the 27, so minus 8x. And that 27 is positive, so I need to put an addition sign to verify that that is a positive number. Now on the left side, the 8x's cancel. So on your paper, if you were doing this by hand, I would probably just cross those out and move to the next line. I don't think I'm going to have that much room to show my work here, so I'm just going to delete that. In Math 108, you could go ahead and leave that and just keep showing your work, but I kind of have everything kind of pre-programmed in here. Okay, so now that I have my 8x moved over, I need to isolate the y by dividing everything by this -3 out in front. So divide by -3 here. And remember, when we divide, we have to divide both sides, but you have to divide every single term. Just like we did in the previous sections where we multiplied every single term by the least common denominator. When you're doing stuff with fractions, you either multiply every term or, in this case, divide every single term. So divide by -3 in every single one of those cases. So now on the left side, the -3 divided by -3 is 1. 1 times y is y. And now we have isolated y, and we have one more little thing to complete the slope-intercept form. So I have a -8 divided by -3. That means I get a positive number, negative divided by a negative. And you'll notice that I'm going to go ahead and keep this as an improper fraction. The reason I'm doing that is slope is rise over run. I could change this to a mixed number, but I would rather keep it as my rise over run, especially when we're graphing. So leave it as its improper fraction, x, times by my 8/3, and then I have a positive 27 divided by a -3. A positive divided by a negative is negative. 27 divided by 3 is 9. There we go. now that I'm in slope-intercept form, I'm going to go ahead and highlight this as my answer. And I'm going to come down here and just for our sake, I'm going to say m is my slope, or 8/3, and the y-intercept, or b, is -9. So this line is intersecting the y-axis below the origin at -9, which makes it very convenient for when we do our graphing, which comes in number 7. All right, let's move to the next one. So here I have a negative 3x, and I still want to isolate that 5y, or the y, but the 5y first. So I'm going to add 3x. I'm going to go ahead and try just a little different here. If I were doing this by hand, you don't have to rewrite the whole problem like I did up here and do the 8x minus 8x on the same line. Some people will just do this, and then it shows that I can cross these out, and I can do that by crossing it out with my pencil. And then on the left side, it shows that I've canceled these out, and I added 3x because I had a negative, and the only thing left over here is 5y. So 5y equals, and again, I want to put the 3x first so that it matches my y equals mx plus b form. So I'm going to put my positive 3x, and I don't need to put a plus sign because it's positive, and the 10 is positive, so I do need to say that I'm adding these two together. There we go. And the last step will be divide every single term by 5. So to do that, to try this new way, I'm just going to put a 5 underneath every single one of these. There we go. And doing a division sign. So I would be dividing here and here and here. And then 5 divided by 5 is 1, or you can say it cancels, and I'm left with y, which is good because that's what we wanted to isolate. So y equals, and I have 3 over 5 here, times the x, and 10 divided by 5 is 2. And there we go. And if I wanted to break this down, I could say that the slope is 3/5. That means I rise over run. I rise up 3 spaces, and then I run to the right 5 spaces for the rise over run for the slope. And the plus 2 at the end, this is the y-intercept, so it's crossing the y-axis up 2 spaces, which makes it easy to graph. Okay, let's try this last one, going from standard form to slope-intercept form, and then we're going to go backwards for the next 3. Okay, so again, we need to get rid of this 12x, so the opposite operation here will be add 12x, and I need to add it to both sides. And so on the left side, the 12x's cancel, and I'm left with this negative 6y equals, and make sure you put your 12x first. The other 12 is positive, so we'll put plus 12. And then I can divide everything by a negative 6 to continue isolating that y. And don't forget, it goes to every single term. All right, and here the 6's will cancel. So I'm left with y equals 12 divided by negative 6 makes that negative 2x. And then positive 12 divided by negative 6 is minus 2. There we go. And so I could talk about the slope and the y-intercept again, where the slope here is negative 2. Now that one's a little harder to graph, so what I like to do is make it a fraction, and all whole numbers can be put over a 1. And that's nicer because then you can go back to the definition of rise over run. And when it's negative, I'm not really rising because it's negative, so I'm dropping down to and then a run of 1 means I'm running in the positive direction to the right 1. And my y-intercept is that last number, and I take the sign with him, so that's -2. That means down 2 spaces on the y-intercept. All right, let's go from rewriting in slope-intercept form to standard form. I have a couple of different ways I can do this. My favorite way is to just obliterate all fractions, which is really nice, especially those of you who have a little bit of anxiety with the fractions. And in these cases, it's really nice because I don't really have to look for a least common denominator. I just look at the only denominator that should be here, which will be the bottom of the slope. In this case, 5. So I need to multiply every single term by 5. So I would do, if I were doing this by hand, I apologize for the lack of ability here, but I would say times, and I would find a little space, put a 5 here, and make sure I times 5 here, and times 5 here. So then my next line will say 5 times y is 5y, and then 5 times 2/5. That gives me 10/5, which simplifies to 2. Or you can think about it as canceling out the top 5 with the bottom 5, which only leaves you with the 2. Either way, you have 2x, and then I have 5 times 5 for the end, and that's positive, so plus 25. Now that's the fast part. Now I just need to keep going, make sure that the x and the y are on the left side and everything else is on the right. So in this one, I need to move my 2x over. Because it's positive over here, I need to subtract 2x, and I can show that like this. Some of you will get to the point where you can say, I'm moving the 2x over, and every time it crosses the equal sign, it changes its value, so a positive to a negative and a negative to a positive. Those of you who like writing down every single step, don't worry about it and go ahead and keep writing it out as -2 on both sides. And then we can say that it cancels here because 2x minus 2x is 0. And I have this -2x and the 5y. And remember, in standard form, the x came first. So it's -2x plus 5y, and 25 is the only thing left on that side, equals 25. There we go. This one is just standard form. It doesn't have any major convenience like the slope-intercept form, except that some of your questions will ask you to put your answer in standard form. All right, let's try this one. Let's go ahead and get rid of the fraction again. If you didn't want to do that, you could get rid of the fraction later, and that would be moving the x over and then multiplying everything by the least common denominator. I like to get rid of it first, so I'm going to go ahead and do it that way. And let's go ahead and do it the same direction so that you can see you can do it by hand. The least common denominator, or the only denominator here, is the 3. So I need to multiply every single term by 3. That term. And terms are separated by the addition sign, a plus sign, or a negative sign, a subtraction sign, or the equal sign. So here I have 1, 2, 3 terms. So over here I have 3y. Oops, next line. 3y. Here again we can think of as the 3 and the 3 canceling, which leaves me with the -8x. And then a negative times a positive is -21. Now I need to move my 8x over. Those of you who want to think of it as just coming over here, you would move it across the equal sign and change its value so it becomes positive. Those of you who want to keep showing all the steps, that's fine. You'll put plus 8x and plus 8x and show that the 8 cancels over here. And again, the x comes first, so I need my 8x plus 3y, And the only thing left on this side is negative 21. And that's our answer in standard form. All right, let's go to our very last one. I'm going to go ahead and get rid of the fractions just to stay consistent with what we did in all of the other sections as well, and multiply everything by the least common denominator. In this case, the only denominator, 4. So times this by 4 to every single term. The 4's will cancel here. Oops, don't cancel out the 1. And so I have 4x, or 4y, equals, the 4's canceled, so I have a 1, but 1 times x is just x, so I'm going to leave that. And then 6 times 4 is 24. Now I need to move my x over, or those of you who want to say I want to do it to both sides, you would say subtract x. And the x's would cancel here, and the x needs to go on the left or the first, so it's negative x plus 4y equals negative 24, because that's the only thing left over on this side. And that's our answer in standard form. Now you'll notice on my right side that I have two answers over here. I could multiply everything or divide everything by a negative, which would make it x minus 4y equals positive 24. So there's a couple of different ways depending on what different answers are available in your multiple choice. The negatives might be off slightly, but standard form, you do have to have all whole numbers. You can't have fractions, so you can't just subtract the 2/5 to the left side and leave it as 2/5 x on number 4. So make sure you get rid of the fractions. All right, now that we've had some practice with that, let's move on to number 7, where we actually graph. So here, the first thing I'm going to do is do what we did in the first 3 examples, which is rewrite this in slope-intercept form. So I want to subtract the 8x over so I can work on isolating the y. And we can do that by saying minus 8x. And then make sure you subtract it from this side, minus 8x. On the left side, the 8x cancels, and so I'm left with negative 3y. Then, because I'm looking for slope-intercept form, the negative 8x must come before the 27, so minus 8x plus 27. And then finish isolating the y by dividing every single term by a negative 3. There we go. And if you're doing this by hand, which most of you will be doing, you'll have a division sign here. And the negative 3's will cancel here, which gives me y. And that's what I wanted for slope-intercept form. Negative 8 divided by negative 3 is a positive 8/3 x. A positive 27 divided by a negative 3 is a negative 9. All right, now the convenience here in rewriting it in slope-intercept form is that I can graph this much faster. So what I do is it says graph the following lines given one point and the slope. Because I have slope-intercept form, I have the slope, so check here, 1 point. This is the y-intercept, so that's my 1 point. If you're not comfortable with that, you can go ahead and make a t-chart, and I've given my two favorite ones, which would be the y-intercept and the x-intercept, because if you just plug in a 0, it's much faster to calculate. However, I will be sticking with the y-intercept. So here, slope, intercept. So even though it says slope-intercept form, you go to the intercept first. This is the y-axis, negative 9. All I did for this to show you is I went and did a Google search for a graph from negative 10 to 10, copied and pasted it in here, and then here I inserted just a shape. I made a circle and I filled it in black, and I made it as small as I could so that I can just graph that on here as a point. So now that I'm looking for my x-intercept or my y-intercept is -9. My y-axis, remember, is the tall one because y is tall, and I come down here to -9 and just try and get that square on there. You will probably be doing yours by hand with graph paper, or you've made your own with little tally marks, and that's fine. Feel free. Okay, now that I have 1 point, you must have 2 points to draw a line. So here's my first one, is the y-intercept of -9. So where do I put this other point? Just on the graph? What I do is I take this slope, and remember the definition is rise over run. From this point, so many students go back to the origin. Don't go there. We went to a lot of work to find this y-intercept. From this point, the slope is a rise of 8 and over 3. So I get my next point, and I rise up 8 from here. 1, 2, 3, 4, 5, 6, 7, 8. Because I have a positive 8/3. So that's a rise. That's exactly what slope means, rise. Now over run, that means I need to run 3, a positive 3. The positive direction for running is to the right, just like the x-axis has the positive numbers on the right side and the negative numbers on the left. So positive 1, 2, 3. And that's where my next point for my line should be. There we go. Now if you want to check or double check and just do a t-chart and find another line, that's up to you. I'm confident and comfortable with this to go ahead and connect these. If you're on your own paper, you can grab some sort of a straight edge. Sometimes it's just another piece of paper or a pencil or even the edge of your calculator to make this a straight line. And make sure you put arrows on both sides, because even though our dots have stopped here and here, the line doesn't stop. It continues to go in either direction. We just haven't found all of the millions and thousands of infinite points that connected together give us this line. So go ahead and put your arrows on, and we've graphed our line. All right, let's try the next one. Again, we're going to start by rewriting this as slope-intercept form because that makes it so much easier to graph. The first thing I want to do is move the 5x, so I'm going to subtract 5x from both sides. There we go. And so on the left side, the 5x cancels, and you'll cross it out with your pencil, and we have negative y equals, and on the right side you want the x to go first, so put your negative 5x. The 10 is positive, so we put plus 10. And it looks like we're in y-intercept form, except I have this little negative sign. That means I need to divide every single term by a negative. And I'm just going to do this by negative, and because I can't just put a negative there, I do -1. And if you're not comfortable with that, remember, all coefficients, if there's nothing there, you can instantly put a 1. So when I divide by a -1, what happens is the value of each of these changes, and it becomes positive y equals a positive 5x and a minus 10. Okay, so now I have a slope and a y-intercept, and I'm going to go ahead and write it out here, especially for you visual learners. The slope here is 5, and the y-intercept, or b, you can do either way. You can put b, or you can actually write out y-int, is a -10. Now some of you are thinking, wait a minute, slope needs to be rise over run. That's the definition. How do you graph 5? Always put it over a 1 if it's a whole number, because then you have a rise over a run. Some of you might be okay at this point to say, I understand that all whole numbers can be rewritten with a fraction over a 1, but I kind of think that most of you will like putting it over a 1, especially you visual and tactile learners. Tactile meaning you like to hold things and see it in your hands. And everyone learns differently, so whichever way works for you. Now I have my two dots that I've already created, and I'm going to go find my -10 on my graph. On the y-intercept, so I go straight down here to a -10. I can't see it very well. Oh, that's because it is bring to the front. There we go. It was hiding behind it. There we go. All right. Now again, remember, we don't go back to the origin. You always go to the dot you just did. And I'm going to bring this one to the front too, just in case on these ones really quickly. Okay, now from this point, I need to rise overrun 5/1. So from here, I'm going to rise 1, 2, 3, 4, 5 points, 5 dashes, 5 places, and then run 1. And it's a positive 1, so I go to the right. There we go. And again, I'm going to give myself a double arrowed line, and it doesn't stop. Even though the graph even stops at 10, it doesn't stop. There are infinite number of points here. And I connect my two lines, or my two dots. There we go. Okay, let's try the next one. Oh, it's already in y-intercept form for us, so that'll speed us up. Let's just go ahead and tell us the slope is 1/2. You know what? We haven't had a negative slope. I'm changing this right now so that you can see the difference here in negative slopes. Remember, we talked about in the previous section, if I were to put a skier on the left side and move from left to right, and they had to stay on the line, in this case, my skier would have to be walking up. So that's a positive slope. If I had a line going in this direction, my skier would be having a joyride and going down. So that would be a negative slope. So this one should be going down in this fashion. Let's double check. Okay, so we have a slope of -1/2, and then we have a y-intercept. We can put b, or we can say y-int, it's up to you, is a +8. And so I'm going to get my first dot, and I'm going to go up 8 on the y-axis to a +8. And then I'm going to go from here. The rise over run is -1/2. That means I rise -1. Now that seems kind of like a dichotomy, like it doesn't make sense. It's opposite, rising a -1. Well, rise means I need to move up or down, right? So in this case, I'm going to move down one spot here. And then the run was a +2, so I need to move 2 places to the right. And you'll notice that even though it was a negative, all of these you'll be moving to the right because you don't have a negative on the bottom of a fraction. There we go. So now I connect these two, and you'll be grabbing a paper or a pencil or a edge of a calculator here, line those up, and that's our line. And that's how you get a negative right here, so that it's going down in that fashion, opposed to this one where from left to right it's going up. So that was the positive slope. Thanks for bearing with me. That was fun to change that up last minute. Okay, here we have y equals -4x. So in this case, it's actually already in slope-intercept form. The y is isolated. So let's talk about the slope and the y-intercept, or b. The slope here is -4, and oops. Again, I'm going to put this over a 1 so that we can see that we are moving with a rise over a run, and the rise is a -4 and the run is a +1. But wait a minute, there's no b here, which means the y-intercept is 0. So I'm going to double check these guys are up in the front just now so I don't have to worry about it later. Okay, so now I need to go to my y-intercept, which in this one is right here at the origin, 0. And then from this point that I just plotted, I need to go from here down 4, 1, 2, 3, 4, and run a positive 1 this direction. And that gets me my second point. There we go. Going to insert my shape, my double-edged line, and kind of eyeball that. I hope I can get these in the same line here. I'm going to move this over. You'll have better luck lining those up first on your paper, doing that by hand. There we go. Okay, let's move to the next one. X equals 6. This one is not in y-intercept form, but we learned in the previous section that when I have x equals 6, it doesn't matter any y. I can plug it in and I will always get x being 6. So I'm going to come over here and find where x equals 6. Well, here's one spot that x equals 6. In fact, here's another spot, and another spot, and another spot where x equals 6. This is the spot, the point 6, 5. This is the spot 6, 10. This is the point 6, negative 9. So any of those points, I can toss my next dot because it doesn't matter, and then graph my line, and there we go. That is x equals 6. So you might be getting more familiar with this when I have an x equals. I end up with a vertical line. So in this case, what was the slope? If you remember back, if I'm doing my skier, in this case, he has nothing. So we hope he has a parachute, and it's undefined. He's falling indefinitely, so it's undefined. All right, let's move to the next one. Y equals negative 9. In this one, just like the x equals 6, I come down to y equals negative 9. Oops, bring that to the front. And all across the bottom is where y will equal negative 9. Meaning I have a horizontal line. And all of these down here have y values of negative 9. And the slope here, remember my skier? If he's standing here, he's not going to be moving. He's just standing. So the slope here is 0. All right. And this last question, or 5, is filling in similar to part A, number 29. We have the question to write 5 equations with a slope of 2/5. So all I need to do is give myself the slope of 2/5 and give my y-intercept some number. And the next one, again, 2/5 and some different y-intercept. And again, 2/5 with some different y-intercept. And another with the same slope. In this case, I'm going to give myself 0 or leave it as just 2/5. And one more of 2/5. It has the same slope with another y-intercept. So all you need, 5 different equations. These will all be parallel, but they cross the y-axis at a different point, and so they're 5 totally different equations. All right, I hope you join me for part 2. Good luck on your homework.